Have you ever wondered what's really going on up there in the night sky? Well, we've got some mind-blowing information to share, and we'll break it down in easy, everyday words. There's a peculiar occurrence in our galaxy. It's spinning at such a rapid pace that stars should be dispersing, yet something is preventing their separation. The enigmatic force acting as a gravitational adhesive is known as dark matter. However, its nature remains shrouded in mystery because it doesn't emit light, eluding direct observation. The composition of dark matter is also unknown, giving rise to numerous speculative theories. To maintain stability in our galaxy and others, physicists posit that there must be significantly more dark matter than regular matter in the universe. But how much more? Recent efforts by astronomers, utilizing the Hubble Space Telescope and the European Space Agency's Gaia star map, aim to estimate the total mass of the Milky Way galaxy. This task is no easy feat, primarily because measuring the mass of something we're situated within is challenging. The Milky Way spans about 258,000 light-years, and the abundance of stars and gas obstructs our direct view of the galactic center. Recall that 1 light-year equals 5.88 trillion miles. Yes, the galaxy is enormous. The astronomers tackled this challenge by measuring the speed of certain objects in our galaxy and deducing the mass based on that data. The faster the objects, the more massive the galaxy. Scientists concluded that the galaxy has a weight equivalent to approximately 1.5 trillion solar masses. This figure helps emphasize how incredibly small we are. Consider, for example, the placement of stars within the Milky Way. If you happen to experience a completely dark, clear sky for stargazing, you may witness up to 9,000 stars overhead, those visible to the naked eye. However, within our Milky Way galaxy alone, there are another 100 billion stars, or more, that make up just 4% of all the matter in the galaxy. An additional 12% of the universe's mass consists of gas, including planets, ourselves, asteroids, all of which contribute negligible mass in the grand scheme of the galaxy. The remaining 84% of the galaxy's matter is dark matter, as explained by Laura Watkins, a research fellow at the European Southern Observatory and a collaborator on the project. The vastness of the galaxy and the enigma surrounding its composition are challenging to comprehend. To illustrate this, we've created a visual representation using the recent ESA Hubble findings, a tower of mass. You'll observe that all the stars in the galaxy merely make up a searchlight at the top of the building. As for the majority of the floors, well, what occurs there remains a mystery. Let's picture the weight of the Milky Way in an easy way. First, look at Earth. It has a mass of 5.972 times 10 to the power of 24 kilograms. Compared to the Sun, which is 333,000 times more massive than Earth, Earth seems small. Now, think about the 100 billion stars, or even more, in our Milky Way galaxy. That's a massive number. It's hard to wrap our minds around just how big the Milky Way's mass is, 1.5 trillion times the mass of the Sun. It's truly enormous. An additional 12% of the stuff in the galaxy is simply gas drifting between stars, mostly made up of hydrogen and helium. This is what the gas looks like when we use the same visual scale. Now, what about black holes? Black holes are the vacuum cleaners of the galaxy. Even though we can't count them all, their contribution to the galaxy's total mass is just a tiny fraction. It's a bit tricky to pinpoint the exact amount they add to the total mass because we don't know how many exist, but it will be an incredibly tiny fraction, explains Watkins. The supermassive black hole at the center of the Milky Way weighs around 6 million times as much as our Sun, which is really small compared to the entire mass of the galaxy. And when you compare it to the most abundant, mysterious stuff in the galaxy, dark matter, it's minuscule. Remember, 84% of the galaxy is made up of dark matter. Dark matter doesn't seem to interact with regular matter at all, and we can't see it. However, our galaxy and the whole universe wouldn't stay intact without it. Scientists guessed its existence when they realized that galaxies spin too fast to stay together with just the mass of stars. Imagine a carnival ride that spins people around. If it spun really fast, those riders would fly off. Taking dark matter into account, along with the gravity it creates, made their models of galaxies stable again. There's more evidence for dark matter. It seems to have the same gravitational lensing effect, meaning it warps the fabric of spacetime, just like regular matter. Now, let's try to picture how much dark matter weighs, and see how it compares to the weight of stars and gas. And don't forget, what we've been talking about is only our galaxy. There are hundreds of billions of galaxies in the universe. Also, keep in mind that dark matter isn't even the most significant mystery in the universe when we think about its vastness. About 27% of the universe is dark matter, and only 5% is the matter and energy that you and I see and interact with. The rest, 68% of all the stuff in the universe, is dark energy. This dark energy is making the universe expand faster. While dark matter helps hold individual galaxies together, dark energy is pushing all the galaxies away from each other. What you see in the night sky might seem huge, the thousands of stars and solar systems that could potentially be explored. But that's just a tiny part of what's truly out there. That concludes our cosmic adventure. If you enjoyed this journey, hit that thumbs up, and don't forget to subscribe for more cosmic content. Keep looking up, stay curious, and thank you for joining us on this cosmic exploration.